Today what we're going to be looking at is the Nantucket Atheneum's 3D printer. We got this 3D printer, I would say, about 6 months ago. And we've been sort of using it and printer for that amount of time. We've been kind of testing it out to see what we can do with it, how it might fit into the library, how it could fit into educating the community about what 3D printing is, and also the great tool it is to produce things. So let me first start off by describing the 3D printer itself. What we have is, this is a MakerBot replicator. This is the 5th edition of a replicator, and the replicator itself is a 3D printer which uses a polymer. Polymer is sort of like a plastic, except what we use is sort of a bioplastic. The plastic is made out of cornstarch, but actually any sort of starchy material can be used. In the United States, cornstarch is probably the most readily available type, but you can actually use any type of starch to produce a polymer. So the polymer on this particular machine gets extruded through a tractor feed into a heated nozzle. The heated nozzle heats up the material between about 215 to 230 Celsius. That's like 2.5 times the amount of heat needed to boil water. So it's extremely hot. So when it tractors in the filament and it melts it, it then extrudes it as a very fine, sort of hair-thin string. And then it lays down that string from the base of the material product you're trying to use, the object you're trying to make, all the way up. So on the 3D printer itself, you'll notice that the print head moves around, and each time it's moving, it's actually adding a layer to the actual object that we're creating. So it's sort of an additive process. There's all different types of 3D printers. Yes, the objects on the table are actually 3D prints. There are all different types of 3D printing. Some 3D printers print in polymers, some print in nylon, some print in metal, some print in ceramics, and there's even a movement to start printing entire buildings, and those buildings would be printed out of cement or concrete and rebar and other things. So, and there's other types of 3D printing. All those that I talked about are sort of additive processes where it builds it up from the base upward. There's also liquid polymer 3D printers. Now, a liquid polymer 3D printer, it doesn't heat the polymer. The polymer is already in liquid. What it does is it hardens the polymer, and it uses basically a UV laser to do that. If you've been to the dentist in the past couple years and got a really fancy filling, perhaps one that looked like tooth enamel, they might have brought out a sort of an infrared sort of light, and they shine that on the material that they put, and then they polish that down. And so that's like sort of a type of liquid polymer that hardens when it's exposed to that laser light. And very many of those printers actually print from the top downward, or it actually lifts what you're working on just below the surface of the polymer, and then the laser adds a new layer and it lifts it up and lifts it up. So, cornstarch. All these objects on the table are made from cornstarch. And this particular material comes in all the different colors of the rainbow. So red, white, blue, gray, black. We even have clear polymer, which was used to make this little skull, this cat skull, saber-toothed cat skull. Doesn't look like your house cat. We also have a glow-in-the-dark filament. So that filament you can use to make all sorts of things. So if you wanted to make a glow-in-the-dark piggy bank, you could do that. So the filament itself is very versatile. Now it is a bio material. You could put this in the ground, and probably after a few years it would break down, and it breaks down through water, heat, and actually bacteria in the soil. You need all three of those things to really break down the material, but it does break down into basically cornstarch. So that's why we actually chose this particular printer, is that we felt like it wasn't going to be adding to the trash pile on Nantucket. We actually wanted something that was, you know, environmentally sound and safe. The other nice thing about it is it's incredibly tough. It's very strong. You probably wouldn't notice like the difference between this piggy bank and one that was injection molded from a factory, you know, in another country. Very strong material, so it doesn't really degrade as far as in UV light or sunshine or in water. I actually had these particular things are actually Christmas ornaments. We had these on the Nantucket Atheneum tree, and they spent a good 6 weeks outside, no worse for wear. Would probably take a little over an hour. This particular object, it's very flat, as you can see, but it would, in order to lay down all the layers, and because there's a kind of a component in here that has many arms on it, it takes a little bit of extra time. If you're going to print, like, say, something extremely flat, something like this might take 45 minutes or something like that. This skull took about 3 hours. So the main thing I wanted to show you today, as well as answer your questions, is, well, we got the 3D printer. That's great. It makes 3D objects. But you might be interested in maybe creating your own 3D objects, or you might be interested in finding what types of 3D objects could be printed. And so one of the first places I'm going to show you is a place called Tinkercad. Tinkercad is a free online computer-aided design program. That's what CAD means. Because it's free and because it's online, you don't need an extremely powerful computer. All the computing is done at the server somewhere in the Midwest, and so therefore you can use Tinkercad on any type of computer, and you'll actually have a very smooth experience. So we have the 3D printer here. We really encourage people to come in. They can contact me. I'm Lincoln Thurber. I'm the head reference librarian upstairs. And so if you're interested in printing an object or just discussing something you'd like to design or find, we can help you out.